Okay, hello, welcome to my channel. My name is Ivan, and in this video we're going to discuss about vectors. Right, so this is the very first video on a series devoted to vectors. Good. Okay, so we'll be looking at, of course, we know vectors already to be defined as a quantity, right, physical quantity that has magnitude and has direction. Good. But here we'll be looking at it on a very abstract base, where we think about the vector as a directed line segment. In other words, we just get a line segment and then give it some direction, and then we call that a vector. Good. Which has a size. So the length of that line will be the size of the vector, which we call magnitude. And then the direction. Okay, so in this case, you can say something like maybe northeast. Good. That's the direction of this vector. If it is starting from here, then ends here. Okay, so that's basically it. So let me erase this. Alright, so think about vectors as quantities that have magnitude and direction, or in linear algebra, we can simply say that a vector is an element of a vector space. So we think about vector space, for example, we can say the vector space R2, alright, is a space containing vectors of this form, where the vectors have two components from the real number system. So we say where A and B are real numbers. Good. So this is a typical example of a vector from R2. So we have maybe a vector space R3, that is a 3D space. We can have something like this, say A, B, C as a component vectors. Okay, where A, B, and C are real numbers. Good. So this is a vector from R3. And it's important to note that when it comes to the components, right? So we have component A, which is a component in the x direction, or I can say the direction of unit vector represented by I. Then B will be like in the y direction, where we want to represent vectors, and we can call that a vector pointing in the direction of unit vector J. And then lastly, the Z for the R3. So with that, we can represent unit vector K. Use unit vector K for that. So what we want to do next is to learn how to represent a vector. So maybe let's just get into some examples. Okay, great. So the first example we have here is we want to represent this vector. So I'll say let V be a vector with length, that's with magnitude of 5. Maybe 5 units, whatever units you may want. Then it's pointing northwest, right? So northwest. Good. So you want to represent this vector, a vector where the length is measured as 5 units, could be 5 meters, could be 5 centimeters, whatever, and it's pointing northwest direction. Okay, so we can maybe represent it this way. We can have this vector, of course, northwest is something like that, right? Okay, so that's it. And then we take the measure of this length. So we can measure the length and call that 5. So this right here, we call this right here the vector V. And I forgot the notation. There's a notation we can use for vectors, and I will choose this notation where we have like a little arrow above the letter we use to represent the vector. So something like that. Okay, let's run right into the second example. So for example 2, I would say let's represent this vector. So in this case, we're going to have specific components for this vector. So let U be a vector with components 1 and -3. Okay, so given this, you can easily know that this is a vector from R2, because the components are just 2 components, right? I and then -3. So I is a vector in the 1 is a vector in the I, that is unit vector I direction, and then -3 is a vector in the unit vector J direction. You can say pointing the x and y axis respectively. Okay, great. So this is what we'll do to represent this vector. First of all, I'm going to draw the Cartesian plane. I'm going to draw the y axis and the x axis, and then I'm going to locate these values, right? So since I say 1 is in the x-axis, so we just have to mark where 1 should be. Maybe that's close, that's too close. We have enough space, right? So let's call that 1. And then -3 on the y-axis, so we can call this -1, -2, -3. Okay, maybe let me just clean this up a little bit. Okay, so maybe let's have it as it's supposed to be, so something like that. So that's 1 on the x-axis, and then -3 on the y-axis, so something like this. Okay, so we can represent that vector by saying the vector here is here. Now, this is what we call a position vector, where the vector starts from the origin, or what is considered to be the origin, up to the point of consideration. So in this case, the vector is from the origin up to 1, -3. So this is the vector u that we are looking at. Good. Okay, so I wouldn't bother about finding the length of this vector in this video. That will be in the next video. The next thing I would like to do is to come up with another example, and this time this vector will be in R3. Let's see how we can represent a vector in R3. So maybe let's call the vector W. It's a vector in R3 and is given by 2, 3, and 1. So this has 3 components. Of course, x and y axis will not be enough. We need another axis, right? That means the third axis, which is the 3, that is the 3D space. So maybe let's do this. Let's bring up the vertical axis. We have this, then we have that. Sorry, let me start from here. Good. Okay, so these are the 3 axes. Then we're going to look at this as the z-axis, which will be pointing in the k direction, right? So over here we have maybe 1. Let me just mark that. We call that 1. Then let's call this the y-axis. That is in the j direction. Let's call this the x-axis. That's in the I direction. Alright? That's great. Good. So here, over here we need 3 lines. That's 3 marks for the y-axis. And then for the x component we need 2. Okay. Next thing we'll do here is to locate this point. So this is 2. We will look at that. That's 2. Trace it to where we can meet 3 on the y-axis. So first of all, get the point on the xy plane. So this is 2 on the x-axis, then 3, just like we have over here. Then, how should we locate the point 1 on the z plane? So we need to think about this plane as the corner of a four-walled house, right? So we have a house which is rectangular. That is, as you can look at the plane. Okay. So what happens is that at any corner you can see this edge like this. Good. Okay. So this is like the height, right? So if you have 1 here in the vector, this one you can't be careless about it. You can't care less about it. This is how we're going to represent it. We're going to think of this one as the height of that vector. That is to say, the vector is 1 unit above the xy plane. So it is not on the xy plane, but rather 1 unit above it. So I'm not going to trace it to this point on the xy plane, but rather I'm going to trace it to a height which is 1 unit above the xy plane. So this is how the vector should be, where this right here is 1 from this 0 to 1 right here. So it lies directly above this plane from this origin to this point, but it is above it by 1 unit, right? So if you cast a shadow directly above this line segment, the shadow will be from 0 to this point on the xy plane. That's the shadow be cast upon this xy plane, but the vector is not exactly on the plane. It is 1 unit above it. That is, it comes up like that. Okay, so that is how to represent a vector in 3D. Good. They can give you this to take home to represent this vector given by, maybe let's shouldn't use that. Let me use this notation. Let's say 1, let me not give it too much. 1, let's say 4, and then 3. Good. I think that's not too bad, right? So just do that. Okay, thanks for watching. For my next video, we're going to learn how to find the length of a vector. And then from there, we'll look at other things. Please don't forget to subscribe to my channel, and then we'll continue for my next video.